So we do one section in chapter 11 and two sections in chapter 12. If you were not using StatCrunch, I would need a lot more than a couple of days to teach this, but it's really quick because StatCrunch does all the work for you, which is super nice. So 11.1 is going to have us do inference on two proportions, and it gives you an idea of how you can do inference with two proportions or two means or two standard deviations, things like that. So there's just this one section to show you that. So first we have to understand whether or not two samples are independent or dependent. So a sampling method is independent when an individual selected for one sample doesn't dictate which individual will be in a second sample. But a sampling method is dependent when an individual selected to be in one sample is used to determine the individual in the second sample. Dependent samples are often referred to as match pair samples. It's possible for an individual to actually be matched against him or herself. So for example, a study that looks at how long it takes someone to catch a ball with their left hand and their right hand would be the same person. So some examples, independent or dependent. A researcher wants to determine the effect of alcohol on people's reaction time to a stimulus. She randomly divides 100 adults over the age of 21 into two groups. Group 1 is asked to drink 3 ounces of alcohol, while Group 2 drinks a placebo. Both drinks taste the same, so the individuals in the study don't know which group they belong to. 30 minutes later, the subjects in each group perform a series of tests to study reaction time. So the people that were put in one group are not determined by the people that were put in the other group. So this would be an independent, because there's no matching of the people in the two different groups. Another one, a political scientist wants to know how a random sample of 18 to 25-year-olds feel about the Democrats and Republicans in Congress. So she obtains a random sample of 1,030 registered voters and asks, do you have a favorable or unfavorable rotated opinion of the Democratic Republican rotated party? The word rotated there means she doesn't ask the same question to everyone. Half the time they ask favorable, and the other half they ask unfavorable, half the time Democratic, half the time rotated Republican, and that mixes it up so there's not bias. Each individual was asked to disclose their opinion about each party. So in this case, because they ask a question first about favorable or unfavorable, and then to talk about how they felt about each party, that those two questions are going to be linked together. So that would be considered dependent because of the linking of the questions. It's important to know whether it's independent or dependent because you have different kinds of statistics you'll use for each. So the hypothesis test we're going to do in this chapter is the difference of two proportions. Are two proportions different? So here's an example that we can look at. In October 1947, the Gallup organization surveyed 1,100 adult Americans and asked, are you a total abstainer from, or do you on occasion consume alcoholic beverages? The response was 407 out of the 1,100 indicated they were total abstainers. In a recent survey, the same question was asked of 1,100 adult Americans, and 333 indicated that they were total abstainers. Has the proportion of adult Americans who totally abstain from alcohol changed? Use the alpha equals 0.05 level of significance. So you're looking at two different proportions, two different samples, two different proportions to see if there's a change. So that's how you know you have to use the difference of two proportions test. The initial conditions are very similar to when we had a one proportion test. We have to have a random sample, so now we need to have two random samples. They both need to satisfy n times p hat times 1 minus p hat greater than or equal to 10, and that the sample size n has to be less than 5% of the population size, capital N. So same thing, just you have to do it for both proportions this time, because they might have different sample sizes, they might have different proportions, and they might have different even populations. So the null hypothesis will say that the two proportions are the same. The two proportions are the same. The alternative is either going to be P1 is less than P2, or P1 is greater than P2, or P1 is not equal to P2. So looking at the two proportions from the two populations, the null is that they're the same. The alternative is the first is less than the second would be the first is greater than the second, and finally they're just not equal. We don't know which is which. StatCrunch writes them slightly differently. So instead of P1 less than P2, it'll say P1 minus P2 is less than 0. And for the null is the same thing. It doesn't say P1 equals P2, it says P1 minus P2 equals 0. So if you want to set them up according to the left, because that seems easier, and then just convert them to the right, that might be simpler for you. So I'll do a little screenshot of that one so you can have it. Any questions so far? Okay, so we're just going to do StatCrunch with two proportions. We'll do StatCrunch, proportion stats, 2 sample this time instead of 1 sample. So this is the first time we're doing 2 sample. So this is where it changes right here into 2 sample. And then with summary. And now we get 2 samples that we need to enter, the 407 over the 1100 and the 333 over the 1100, because they had the same sample size. They don't have to have the same sample size. So here's the part that's a little bit tricky. We wanted to know if they were different, so it's a not equal to 0, and it's equal to 0 for them being the same. There are hypothesis tests of other kinds where you're not using 0, but for us, we will always use 0 here. Okay, so we just always use the two proportions are equal, P1 minus P2 equals 0, and then you just have to choose the appropriate choice here for P1 minus P2. So the results look like this, and they give you, just as before, the z-stat and the p-value. So here's your z-statistic and your p-value. In this case, we have p equals 0.0008, so very small. So that means we can reject the null hypothesis. This is definitely less than alpha, which was only 0.05. And we accept the claim that the proportion in 1947 is different than the proportion in the recent survey. So the null hypothesis says they're the same. There's no change. Remember that null is no change. The H1 says there's change. It may be that P1 minus P2 is not equal to 0, which is the one we just did, where we don't know whether it's a positive or a negative change. Or it could be P1 minus P2 less than 0, or P1 minus P2 greater than 0. But in this question, it just said, is there a change? It didn't ask us which way. So it's pretty similar to what we did in chapter 10. I did put a template for this into your notes for today. So if you want to keep using a template like we did for the other hypothesis test, that's in there for you. That's it for 11.1. It really is that simple. So there's a few homework problems in there to practice, but it's very similar to chapter 10. And that's the only section we do in 11. Any questions?
So, like, with the two samples, is it basically a stat crunch taking, because there's only one set of hypothesis test results at the bottom there.
Yes,
So
because,
it,
go ahead.
no, I was gonna say, so it combines the two? Is that what's happening?
Yes, what we're doing is comparing the first proportion to the second proportion to see if they're equal or if they're different.
And where does it go? Can you go back to the total part, the next slide?
Yeah.
So I'm just not understanding how to read where it's different. Like, to, you know what I mean? To like tell that it's different.
It's the p-value. So we know
Okay.
that the first one we had. Let me walk you through a little bit of what's here in StatCrunch, because that might help.
Okay.
So this was our first sample,
Mm-hmm.
107 out of 1100, and our second was 333 out of an 1100. So they're definitely different.
Yeah.
This tells you how different they are. Okay,
Okay.
this is how different they are. You don't need to know this, but if you like it, it helps.
I think it's just going to help with my brain with.
Yeah, so the question is, are they different enough because they're just samples?
Mm.
Are they only different enough because they happen to be samples? Or are they so different we go, wait, those populations have to be different too?
Okay.
Okay, and the p-value tells you whether the populations are different.
Which they're really
They are.
not.
Yeah, so the p-value is less than alpha says the populations are different.
Okay.
So, for example, maybe I wanted to look at the proportion of students at 4Cs who have dropped out since the classes went online. And then we also want to look at a community college up near Boston and see if the results are the same or they're different. Does that make sense? So we might say, well, I think it's going to be worse near Boston for some reason. I don't know. Or maybe we'll say it's worse on Cape Cod because the internet isn't as good as it is near Boston. So we want to look that and see if they're really different. Now, they're probably going to be slightly different, but the question is, are they different enough to say they're really different? Because we're not going to talk to every single student from the two places. We're just going to do a sample. Okay.
So how you say that this one with the 0.0008, there it is different?
The p-value is less than alpha.
Okay.
It's always when the p-value is less than alpha. Let me get another color. So if, oh, that's not good either. Back. If the p-value is less than alpha, we reject the null hypothesis. And the null hypothesis says P1 is equal to P2. It says P1 minus P2 is 0. In other words, P1 equals P2. And we're rejecting that they're equal and saying that they're different. Does that help?
Yes, I
Okay.
get it now. Thank you.
Sure. Anybody else? So there's a few homework questions on that, not a ton. I did 3 separate homeworks because I didn't know how far we'd get and I didn't want to rush things. So I just did them separately. The last one only has 2 questions because it's so simple.
So the p-value meaning the 0.05?
The alpha is the 0.05,
Yeah.
right? The p-value is this 0.0008.
So if it's less than the 0.05,
Right.
rejected. Okay.
Other questions? Okay.